Greetings ladies and gentlemen. You are watching the final year project presentation entitled Development of a Heat Transfer Analysis Software by using Microsoft Excel. Let me start off by introducing the people involved. My name is Soo Jun Chun with a metric number of DD180065. My first supervisor name is Haji Muhammad Azwir bin Azlan, and my second supervisor name is Professor Madya Dr. Mohammad Kamil bin Abdullah. With that, I will continue this presentation with the introduction. First of all, background. Heat transfer is a third-year compulsory course under the field of mechanical engineering. It has been categorized in three main types, which are conduction, convection, and radiation. Conduction is happening when there is a temperature difference between two connected solid surface or inside a solid body itself. To solve conduction problem, the Fourier law of conduction is applied with the equation shown, where K is the thermal conductivity, A is the area perpendicular to heat flow, and delta T is the temperature gradient in x direction. Convection occurs when there is a temperature difference between a solid surface and the surrounding liquid or gas that is in motion. We use Newton's law of cooling to deal with convection problem. The equation is shown with H as the heat transfer coefficient, A is the surface area, Ts is the surface temperature, and T infinity is the ambient temperature. Radiation, on the other side, requires an emitter, or also known as a heat source. Every object, no matter living or non-living, with a temperature above 0 Kelvin will emit radiation to its surroundings. The Stephen-Boltzmann law is applied here to solve the radiation problem. Eta in the equation is referred to the emissivity. Sigma is the Stephen-Boltzmann constant, A is the surface area, and Ts is the surface temperature. Moving on with the problem statement. I will express this by telling a story. Fikri is a third year of mechanical engineering student taking his transfer subject. He often struggles with manual calculation with lots of equations and figures need to refer. He also makes mistakes sometimes because of miscalculating the complex equation. To further emphasize this, I had conducted a research by myself inside the campus. It was found that about 7 out of 10 university students prefer software calculation over the traditional manual way. Hence, this triggers the objective of this project, which is to design a system that can analyze heat transfer problem in order to get some important parameters which are needed for engineers to determine the characteristics of heat transfer between two mediums or design a heat transfer system. There are 6 scopes in this project. The first one is targeted in the field of heat convection, which covers both forced and natural convection. The second one is targeted in the field of heat conduction, which covers thermal resistance concept and thin surface. The third one is targeted in the field of heat exchangers, which includes both loft mean temperature and effectiveness NTU method solving. The fourth one is able to obtain certain parameters which are crucial in heat transfer system analysis, such as the heat transfer coefficient, temperature variation, heat rate, drag force, pressure loss, and efficiency. The fifth one is focused on the heat transfer analysis process between two solid surfaces or a solid medium or a solid surface and a fluid medium. Followed by the last one, which has certain limitation, including the fluid needs to be incompressible. The heat transfer process must be steady, and the system is only available for one-way problem solving. There are several significance of study in this project, such as the ability to analyze heat transfer problems and display relevant answers which are needed for engineers to study the heat transfer system and bring benefits especially for students in mechanical engineering, whenever they are designing a heat transfer system. The user-friendly software which successfully developed will be able to speed up all the cumbersome process which requires before this, and get to the results much faster. It can also help examiners during the marking process of papers since it can get a much accurate results in a much faster time. That's it for chapter 1. I will continue with chapter 2, which is literature review. The first type of review is the book review. For this, the Heat and Mass Transfer 5th edition by Yunus A. Chungal and Afshin J. Gujjar has been selected. It discusses about the fundamentals and theories of heat transfer and consists all the formulas, tables, and charts that are needed as the main source of the development. There are 7 subchapters that being touched. The first one is the thermal resistance concept. It applies the concept of electrical engineering and is dealing with multi-layer plane wall or curved wall. The heat rate can be calculated by dividing the temperature gradient with the total resistance value. Some examples of determining the individual resistance calculations such as plane wall and convection has been displayed as shown. Thin surface have been used by engineers to enhance heat transfer from a surface by exposing a larger surface area to convection and radiation. In the analysis process, steady operation with no heat generation is considered. The maximum heat generated by a fin and the fin efficiency calculated has been displayed as shown. All common fin configuration can be found in Table 3.3 inside the Chengao heat transfer book. External force convection happens when a fluid approaches with a relatively high upstream velocity, or known as V infinity, and intersects with the solid body externally. There are two main types involved, which is the flow over flat plate and the flow over blunt body. The fluid properties can be referred by calculating the film temperature as shown in the displayed formula. Internal force convection happens when a fluid flows through a section of a pipe or duct and causes convection to occur due to the velocity of the fluid. The fluid properties can be referred by calculating the bulk mean temperature with the equation shown. The Reynolds number can be determined by taking the fluid properties, the average velocity, and the hydraulic diameter. Natural convection happens solely depending on the difference in temperature between the solid surface and the fluid medium, regardless the fluid is moving or not. There is a term involved in natural convection only, and it is called volumetric expansion coefficient, beta, which can be determined using the equation shown. The higher the beta, the bigger the volume will change. Some different natural convection configuration can be found in Table 9.1 inside the Chengao heat transfer book. Combined force and natural convection often happens in real life, since both types of convections usually happens together. To determine which one dominates which, we can take the Grashof number divided with the Reynolds number. When the value is less than 0.1, it indicates the natural convection is negligible. If it is bigger than 10, indicates the forced convection is negligible. If it is between 0.1 and 10, meaning that neither one of them is negligible and need to consider both in the calculation. Heat exchangers is the device that enables the exchange of heat between two fluids with different temperatures while preventing them from mixing each other. The overall heat transfer coefficient needs to be determined by using the equation displayed, since it involves two types of fluids. There are two methods of solving heat exchangers problem, which are the log mean temperature difference, also known as LMTD method, and the effectiveness NTU method. The LMTD method is used to determine the surface area and total length that will achieve a specific temperature change in the fluid stream of known mass flow rate, whereas the effectiveness NTU method is used to predict the outlet temperatures of the hot and cold fluid streams in a specific heat exchanger. The second type of review is the software review. There are two softwares which has been selected. The first one is SimScale. It is a cloud-based simulation software including the simulation of CFD, FEA, and thermal. Users do not need to install an application which could take up a huge chunk of their computer hard drive space. It also supports the standard 3D files so that the user can import and continue using the CAD systems which they are familiar with. Lastly, it uses a lean simulation workflow that guides the user step by step through the process. The second software is the heat transfer spreadsheet calculation which developed by John R. Andrew on 12 June 2011. It covers all three types of heat transfers, which are conduction, convection, and radiation. Users can input their desired data and Excel will perform the calculation. For the software comparison, SimScale wins in the ease of access part, since it has a website and it is easy to find. It also delivers a very user-friendly interface and it is easy to use. The heat transfer spreadsheet calculation wins in the calculation of important parameters, since it can calculate all of them but only requires the user input the raw parameters. For the diversification, each software has an advantages and disadvantages over the other. That's it for Chapter 2. I will continue with Chapter 3, which is the methodology. For the project implementation, the flowcharts has been created as shown. PSM 1 includes the background study, information collection, project planning, and layout design. PSM 2 includes the software development, testing, exploring the software capabilities, followed by discussion, conclusions, and recommendation. The software development flowchart has been created with the start of creating databases. The interface is then need to be created by according to all 7 different subchapters involved. The last part is the test run process and finish. For the project methodology, the waterfall method is applied here. It has 4 stages starting from the user requirements, followed by designing the software, implementation, and ends with the testing. In stage 1, the requirements of the problem faced by the user is the heat transfer analysis requires to go through a lot of tables and charts and filter out the necessary ones. This process can take up a lot of time and can potentially lead to miscalculations. The primary objective to develop the software is to build an automatic analysis software so that users do not need to go through those formulas and can obtain a more accurate result. In stage 2, all related chapters need to be summarized and created in the form of flowcharts in order to be referred back during the development process. For this, there are 7 subcategories involved and some examples flowchart has been included. In stage 3, the ideas and flowcharts created beforehand need to be applied in order to become a workable software. A user interface need to be created inside Microsoft Excel for it to be operatable by user. Some of the interface includes a drop-down menu, checker box, and command button. In the final stage, the results obtained by the software need to be analyzed to make sure that they are all accurate and follow the right standards. If the calculation performed by the software is acceptable and meet all the requirements, then the development will be considered as successful. If it is not, some further modification need to be made until the software achieves the targeted results. That's the end of the presentation for all the 3 chapters involved in PSM1. My name is Soo Jun Chun. Thank you so much for watching.